Can't see it here yet.
It says you're live.
It looks like we're live. Hang on, we'll go back here. Okay, we are.
Yes.
Hello, everyone.
Hello.
Thank you for joining us. Angie Richard here from the Floating Stories Lab, and we have the amazing Dr. Corina Ciocan from the University of Brighton. Oh, turn my volume down on my phone. Okay, so today we're here in Brighton,
Yes.
the United Kingdom, on a little bit of a grizzly raining day to discuss end-of-life boats and the impact on aquatic ecosystems, which is the center of your work.
Yes.
And how anyone from the community anywhere around the world can get involved through our collaboration, RETIS. So we're going to basically give a merger of our two lectures today, aren't we?
Mm-hmm.
And we're going to be very lucky because we're going to start with Corina's excellent presentation on the issue, and we'll then move into the citizen science work that we've been doing and how people can get involved. So bear with us in case we have some technical issues. It's the first time we've used this streaming live broadcast software. We're going to switch to PowerPoint. Let us know if you can't hear anything. And in the comments, don't forget to drop in your questions. And we'll probably save question time till the after of the presentation. So now let's switch to PowerPoint. There we go. Okay, take it away, Corina.
Brilliant.
Hang on, are we? No, we can't see the PowerPoint. Why? Oh, here it comes.
It's
okay,
coming.
Perfect. There you go. Yep, should be coming now. Yeah, it's a couple of minutes.
I think it's
A couple of delay. Seconds
yeah.
delayed.
Brilliant. So I'll talk you through the problem of the impact of fiberglass in the aquatic ecosystem. And we're going to talk about the three major players here. We're going to talk about the boats, we're going to talk about the material, the GRP, and then we're going to talk about the actual impact and the biological responses that we get from the organism around those fiberglass boats. So now I'm sure that a lot of you know more about the boats than I do. But I am mostly interested in the fiberglass boats, or any boat that will contain fiberglass. And that is because this glass reinforced plastic, or fiberglass reinforced plastic, it has been built about 80 years ago, has been initially created to manufacture coffins in New York, and then because of its capacity to withstand any weathering from water to temperature to UV light and so on, it's been adopted by the boating industry, and that was the major advancement in the boating industry when small boats moved from wood to GRP. And that offered them, a longevity that hasn't been seen in the past. So nowadays, the GRP is everywhere. The boats, most of recreational boats are made of GRP. We have at least 6 million boats in Europe. In the UK, we have around 8% of the population that participate in recreational boating activities. And the boating industry is booming. The markets are showing that there's an increase in demand, and therefore in the manufacture of recreational boats that is going to lead a 4 times the amount of boats in 2027 than the ones that we had just before the pandemic in 2020.
Yes, second. I think we're not getting the full screen for some reason. I think it's only playing like this. But we might we might have to go through
Yeah.
like this.
Okay, that's
Hopefully this is okay. for
that's
everyone.
perfect.
Okay,
Yeah.
sorry to interrupt.
Okay.
Yep.
Are we good? Yeah.
We're on this one now.
Okay. Brilliant. Okay. So, yes. So that material that was initially created to be, a lifetime material is actually showing the cracks. And like anything, anything we manufacture, we actually have to look at what's happening with the product at the end of its life. And unfortunately, for those GRP boats, the end of life is very messy and very impactful when it comes to their footprint on the environment. This is a picture that I took about 4 years ago on a small boat that was upside down on the shore and showing the fiberglass and showing the bits of plastic, also some bits of wood that actually are released into the environment. And this is just normal weathering. It's an old boat. It has been scraping around on the sediment for quite some time, and without the proper repairs, it showed the very core of that GRP material. This is just normal weathering. But what happens when we have, a catastrophic event like this one? And with the Hurricane Melissa just passing through Jamaica and other Caribbean islands, you can imagine that pictures like this are very common on those places. So extreme weather events, crashing through marinas, crashing through harbors are going to leave a trail of devastation with hundreds or thousands of boats that are destroyed, exposing the fiberglasses, exposing the resins, boats that can't be repaired, and they're going to release in the environment a huge amount of particles. Now, some of the pictures that I'm showing you here are just to raise awareness of scenes that you probably see every day walking around estuaries or rivers or even the coast. Abandoned boats that at the first glance seem very part of the landscape, but actually as I found out recently through my research, through my group research, they represent a major contaminant, source of contaminants for the environment. And what is even more worrying is that removing those boats from the environment, it's a very costly affair. And in most of the cases, those are public money that are going to be used to take the boat out, cut it into pieces, or smash it, as you can see in that picture on the left-hand side, and taken to the landfill. A natural resources wells program that ran for 2 years in the D estuary actually came up with some huge costs for boats like the ones on the right hand side, for example, that are submerged or stuck in the mud, to be retrieved, to be cut, to be taken to the landfill. Tens of thousands of pounds for a boat, for an abandoned boat, all public money, to actually get the environment, the area cleaned and relieved of those contaminants. This is a beautiful picture, that a beautiful diagram that would tell you how many hidden sources of contamination are on the boat, because obviously when the boat is abandoned, it's not going to be stripped off any cables, plastic, metals, furniture, anything that later on, under the influence of the wind, the water, the tides, the weathering, general weathering, they are going to release anything from chemical contaminants to microparticulates in the environment. And we have to acknowledge that the boating industry and the shipping industry in general, it's came out very light in terms of responsibilities. And it's only very recently that more and more scientific research and more scientific papers actually point out towards the boating industry as being one of the massive contributors to the microparticulate pollution in the environment. And you have here a couple of papers that have been published by some very respectful groups of scientists around the world, proving that a lot of microplastic that is present in the environment and especially in the ocean actually comes from the boats. At the end of the day, the resin that goes into the GRP and then all the paints that are covering the hull of the boat are mainly made of plastic. And that plastic, under the influence of the environmental factors, water, waves, UV lights, that is going to degrade, that is going to release plastic in the environment. And so a group of scientists from a German university actually support the idea that most of the microplastic in the North Sea actually comes from the boating industry, from the shipping industry, from the boats, from the binders that are used in boat paint. So this is quite a big toll that the environment is taking at the based on the activities involving recreational boats or boats in general. Now, going deep into the actual material, the GRP. As I said, when it was first created about 80, 90 years ago, it was considered, this phenomenon. It was a great material for a variety of applications, but boating was one of the main one. And so a fisherman friend of mine told me that when he got his first GRP boat, he felt like it was Christmas every day because it was so light and so easy to maintain, and he knew that he's going to have it for a long time. So it was embraced, absolutely embraced by the boaters. And it's, it is very well known now how all this molding is happening in the factories, with the fiberglass being laid between two layers of resin. It is also very well known, that the workers in the factory should wear some very specific kit to cover their face, to definitely cover their mouth and nose. Hands should be protected as well, because that fiberglass is very impactful. It's itchy, it behaves like a splinter. It should be kept away from the inhalation from the mouth and the nose. And so there is this acceptance that the fiberglass and the resin are actually toxic, and the workers should be very well protected. Well, the research that we've started related to the GRP and the abandoned boat actually started as a search for microplastic. And this is a campaign that we ran in 2019-2020, just before the pandemic, just before the lockdown, trying to understand the extent of microplastic contamination in Chichester Harbour. We are here in the south of England. Chichester Harbour is a beautiful natural harbour. that has many problems with sewage and contamination in general. And at that time, so 5, 6 years ago, the Harbour Authority was very interested to understand better the microplastic pollution. So we collected sediment, water, but also organism, mussels and oysters, and we analyzed the microplastic pollution in the harbour. It was very striking to see that alongside the microplastic, we also had fiberglass. And at the start, at the beginning, we didn't understand, we didn't know what fiberglass is. Well, why do we find those fibers in oysters and mussels? There was no scientific publication on this topic, and it took us quite a long time and a series of investigations to determine that yes, this is fiberglass, and the fragments, the bits of plastic that we see attached to it are actually the resins. And so the whole thing is coming from boats that are being repaired, scraped in the boatyards, or from boats that are abandoned in the estuary. We found plastic and fiberglass that has been embedded in organic material, in organic fragments, like you see in those pictures, fragments of algae or seagrass on the left hand side on the top, right hand side on the bottom. Those are organic materials. Those are fragments of plants, algae, and seagrass with fiberglass embedded in them. In the middle, you have a picture of a small snail, and also on the left hand side down, a small snail that had almost 27 fibers piercing the small shell of this snail. And a colleague of mine, a scientist from the Natural History Museum in London, told me that imagine that this would be a human being with 27 javelins spearing his body. So we found those atrocious evidence, this atrocious evidence that actually fiberglass, it's very sturdy, it's present in the environment, and then any soft material, whether that is alive or dead or organic or non-organic, any soft material can be speared, can be punctured by the fiberglass, and there is very little capacity for those organisms to actually get rid of those. Now, also the plastic, the microplastic that is present in the environment is actually ingested by the organism, whether that plastic comes from the boats, from the paints, or from those actual resins. And you have here a beautiful representation of oysters that are taken up, smaller fragments in general. Fragments that are mostly up to 100 microns. 100 microns is a tenth of a millimeter. So they do have this preference for smaller fragments, but obviously if anything is present in the environment and they can ingurgitate, they are going to. And we run experiments on mussels to demonstrate that yes, they do actively intake those resins and those fiberglass. And our published papers presented some very oh, that's much better. So our published papers actually demonstrated that they do actively intake those fragments, and then their digestive tubes are all clogged because they're not able to evacuate, to excrete those fragments. And so they have this permanent sensation of being full. They don't actively feed anymore later, and probably in the end it all results in the mortality, high mortality among this organism. We also demonstrated that the distribution in the water is quite different depending on the weight of the plastic. So you would have a lot of plastic that is floating on top of the water. As you can see here in the Chichester Harbour, for example, we found almost 10,000 particles per liter of water in the top layer, the first 5 millimeters, 6 millimeters. And then that concentration decreased as you go in the deep in the water. So it's obviously common sense that plastic, being very, very light, is going to tend to accumulate at the top of the water, which is pretty damaging, because that's where you're going to get a lot of algae, a lot of zooplankton, small organisms, some of them larvae of, I don't know, crabs, oysters, mussels, lobsters, but also a lot of birds that are actively hunting for food that is floating on the water or just underneath the surface. So that becomes actual food for a lot of organisms. Then you have the fiberglass that usually is heavier than the water, and that is going to slowly sink down towards the bottom of the estuary or the river or the coastal waters, and that is going to become available. The fiberglass is going to become available for any organism that is sitting on the bentos, on the bentic, on the sea floor. So oysters, crabs, lobsters, worms, anything that is living in or in close contact with the sediment, they're going to have access to those fiberglass. We've also demonstrated that this is not a local problem. It's not happening only in the south of England. Fiberglass has been detected by our colleagues from the Desert Research Institute in Nevada on their research that they carried out in Cambodia. They were looking for plastic. Again, everybody is looking for microplastic. Microplastic is such a hot topic at the moment, and it picks, and we understand that it's everywhere. It's in high quantity. It has the capacity to actually penetrate the tissues and to create some huge problems even in the human body. So there is no other way around it. It is a very, very important and impactful contaminant that has a lot of effects in the environment and in when it comes to human health. So our colleagues in Cambodia, they discovered huge quantities of fiberglass in the river. And again, they had no idea why and how that fiberglass arrived there, until they realized that on different sites along the river, there was those massive piles of abandoned boats that were obviously degrading and releasing those microparticles in the environment. And then the river waters would just take those particles away and spread them everywhere. So what we can do, what the future holds, I think the answer is a lot of work, and a lot of work from everybody, from the industry to acknowledge that they have a responsibility for the product. They need to be accountable for the material when that material reaches end of life. And there is an end of life. As we've seen, the boating industry is booming. Everybody wants to be on the water. The boat owners are changing their boat, every few years, because there's always a newer, shinier one with more gadgets on it and so on. So the boats, the abandoned boats, the boats that are not longer wanted, are going to increase in number, and we don't know what to do with them. It's very easy for them to be abandoned. It's very easy for them to be just left rotting in a corner without any responsibility from the last owner, which obviously the last owner of a boat is going to be the one with the less means, financial means to actually take care of the boat for longer term or to dispose of it in an environmentally friendly way. There is not too much investment in research trying to understand the capacity for recycling those boats, but recycling in a very environmentally friendly way without crushing or cutting them, releasing those particles in the environment, and then taking the bits down to landfill where they're going to clog the landfill, obviously. And then it's understanding the impact on the organism and on human health. At the end of the day, the fiberglass, we refer to fiberglass as asbestos-like particles, because pretty much like asbestos, the fiberglass is a natural mineral that is not going to degrade into anything else. The glass is going to be glass in 10 years, 20 years, and so on. And then the fibers are so thin and so small that they behave like splinters. And anybody who touched a fiberglass boat that is cracked or came in contact with that dust that is released when the boats are scraped or repaired or cut, they know that they have itchy hands for about 2-3 days, but then slowly those tiny shards, tiny splinters are going to go away. Once inhaled, it's a different problem. And there are studies showing the deep impact of fiberglass on factory workers. Some studies in United States from the 1990s and 2000 showing that most of the workers are actually succumbing to pulmonary diseases, to emphysemas, because the particles are so tiny, and once entering the lungs, they're going to do what every splinter does, is going to be embedded in the tissue, and it's not going to be able to be excreted, and the inflammatory processes are going to start taking over the tissues, and then other chronic diseases going up to tumors are probably going to develop. So the future is knowing more about it, and it's not only for the researchers to up their game. It's also for the citizen science, for the community. At the moment, a lot of authorities, boating industry included, they need to admit that there is a problem. They need to admit that we are surrounded by those abandoned boats that are decaying and are impacting our environment. And it's almost heartbreaking to think that a boat that once was evaluated at, I don't know, tens of thousands of euros or pounds or dollars, paid by, quite wealthy individuals, then is left to rot and is going to cost yet another tens of thousands of euros or pounds to be retrieved and to be taken to the landfill, but this time using community money, using public money. And so I'm very grateful for absolutely any citizen science support, anything that can raise the awareness of this problem so that the authorities and the industry can come together and invest more into taking care of those boats and invest more into research on recycling, on environmentally friendly way of giving those end of life boats, the end that is not impactful.
Thank you so much, Corina. This is where I, Angie, dive in. We connected about a year and a half ago when I discovered Corina's research as we were creating the Floating Stories Lab, and decided that what we could do was citizen science because of the fact that we were living in coastal communities here in France. So the Floating Stories Lab, for reference, is a French-based non-profit association where we're hand building a 41-foot Polynesian-inspired wooden catamaran for research, storytelling, and community engagement. So whilst we are hand building the boat, and what happened was we were looking at what kind of boat to have before we decided to build a wooden boat, we were looking at a cheaper fiberglass boat. But I also come from 3 generations of surfboard shapers. My grandfather, you mentioned emphysema, Corina, my grandfather died of emphysema. His brothers, who were all marine craft builders, all died from varying forms of lung diseases. So it's something that was close to my heart as a surfer, that I already knew fiberglass was a yucky material. Definitely when you crack your board or you go to a surfboard factory to pick up a new surfboard, you're exposed to the itchiness and uncomfortability. But when I discovered your research, I was really kind of surprised and not surprised. Mostly surprised, actually, at the number of boats dumped in coastal regions, particularly highly biodiverse regions like rivers and estuaries. That's something that you don't really see so much in the surfing industry, because I guess smaller product, when you crack your surfboard, you do pick it up and take it to the déchetterie in French, which is like your landfill or your waste disposal area. Anyway, what we learned was that there was a critical gap in data. When I began to research, I found that no one really knew the exact number of abandoned boats or the extent of the problem. It was almost like being tucked in these rivers and estuaries. They were kind of out of sight, out of mind. So, as a way to get to know my own local coastal environment better in France and to develop friendships with other people who love the ocean, I decided personally to go out and start mapping. And then we realized that this could be a bigger project because it is a global issue, as you said. So we created this global initiative, Regenerative Tides Sailing for Solutions, called RETIS, which is a multidisciplinary citizen science initiative where we combine the data mapping, storytelling, and try to get the community leading this to also drive some policy advocacy. This pamphlet you can see on the screen was designed by an incredible marine biologist who's also an illustrator, Marta. And we have this now available in French, in English. We're working on Italian, Romanian. We have a Japanese one coming, and it's kind of like a quick pocket guide to how to collect the data in the field, observing where boats are left abandoned. And you can see here that with the addition of a little handheld Bluetooth microscope, we can actually see the extent that fiberglass and paints and damage is exposed to the environment from these boats as they're dumped on the shores. So with just a smartphone, a little notebook, and if you can get one of these microscopes, they're about $40, you can actually collect some very important data. And what happens with this data is you upload it to an online survey form, which is anonymous, and it starts to populate into an interactive map. And this is really exciting because anyone from the public, from the marine industry to the researchers to just the general concerned citizen, can actually start to see where we have particularly clusters of abandoned and dumped and wrecked boats, along with all the observational data that's being taken by the community scientists, the citizen out there in the field doing the work. It can take 20 minutes to document the basics of a few boats, or you can spend more time and get more detailed information, whatever is available to you. And we start to have a much better understanding of the kinds of locations that these boats are dumped in, which we're seeing is predominantly estuaries, which are very delicate ecosystems, and the kinds of materials. We are seeing a mixture of wooden boats which are leaching paints, or they've even been repaired with fiberglass and resin, and we're obviously seeing a lot of fiberglass boats as well. What was really exciting in the work we've been doing with Dr. Corina is getting this program into the curriculum of a middle school, a college in France in our local area. Now, this college is located a few hundred meters away from the Goyen River estuary in Plouhinec in Audien in Finistère, and it's right in front of the school is basically a cluster of dumped boats. Some of them are wooden, but wherever you get these kind of older wooden boats that are decaying, and like I said, they're also leaching the plastic paints, you attract more modern dumpings. It just becomes this big dumping ground of composite fiberglass boats as well. So the Euro program at this school combines English and biology, which was perfect for us to introduce this project. Corina came over from the UK and actually trained the SVT, the biology teacher, and the students in how to analyze oysters and mussels that we collect in this river, which are abundant, for searching for fiberglass contamination. We even found on the left here, you can see this is a native European oyster. This species were almost wiped out a few years ago and have been starting to make a comeback. Would you believe that we found microplastics in the gills? You can see the little slide that goes on the microscope. These are samples of the gills the kids are taking from the oysters and the mussels. We've done 3 field trips to the Goyen River and on 3 separate occasions taken different oyster and mussel samples to analyze in the lab. And on every occasion, we've found microfiberglass shards and or microplastics in every sample of gill tissue tested. So when the boats are abandoned, they're exposed to, in this particular river, huge tidal changes, but of course storms and environmental damage. And as you can see from the microscopic photo, which is just one of those handheld microscopic photos, it connects to your phone and you can take a photo or a video whilst you're out there in the field. We can see that this boat here, it is clearly, abandoned, but it's not all broken up and crushed and wrecked as you might think it would need to be a problem, really. But on the tiniest little crack, you get this image on the right-hand side. And we're seeing this on all these boats. And that is exposed, cracked, broken fiberglass, not dissimilar to the shards that Corina showed you previously in her samples that they found in Chichester with the sea fleas. Yeah. So we also promote the merger of creative practice with citizen science. And recently the Floating Stories Lab, as part of our EU Horizon grant for this citizen science project, we held a creative residency. This really drove today's webinar because there were a lot of people who applied we couldn't have everyone, unfortunately, but want to be able to participate to help disseminate the issue and possible solutions through their creative practice. Now, everyone can be a citizen scientist and everyone has a creative capacity. Just taking the photos with a smartphone of the boats and the microscopic pictures is a creative practice and you're contributing. So this webinar is really getting to introduce you to the problem and how you can participate, whether it's mapping and collecting observational data, including the biodiversity of the region you're in, or if you want to then take it a step further. Nathan Myers, one of the participants in our residency, worked with me to create an incredible video that is a step-by-step how to map the boats. That's on our YouTube channel as well. That's an example. There are other people like Marjolaine who took some of these photographs and is spreading the word in her local community. There's artists who are sketching the bad boats, as you can see E2 in the bottom left here. There are so many ways to get involved. So yeah, that's sort of in a nutshell. We're going to take some questions. I've got some questions for you too. Okay. We'll switch back to our desk cam. Okay, one of the questions that we have here from Liza, she's got 2 questions for you.
Okay.
Let's start with the first one.
Okay.
How are other contamination factors accounted for? Things like sewage pollution in certain areas, fiberglass insulation, aircraft exhausts, and so on.
How are they accounted for? Well, there is obviously a lot of research that goes on chemical pollution, because I've been in ecotoxicology for about 30 years now, and I think we went through phases from having a peak of interest in heavy metals, and then it was oil pollution from whatever, oil spillage and accidents. And then it was chemical pollution. And now we go into the pharmaceuticals and the forever chemicals, the anti-flammables that are spread everywhere. And then they are forever chemicals and they're going to last in the environment for a long time. I think what differs between the chemical and the plastic, microplastic and fiberglass, is the fact that whilst chemical pollution is hidden, and it takes a lot for the science to make to raise awareness, when it comes to microplastics and fiberglass, is visible, is there. And I absolutely applaud those pictures taken by a small, handheld microscope, and I applaud the technology actually that is available to anyone. As you said, they're $40, or on Amazon in the UK they're like £15. A microscope you easily connect it to your phone, and boom, you have 200 times magnification of a photo. So this is visible. This resonates with the public a little bit more, and it creates a very clear understanding of the impact on the environment. Chemical pollution is there, and it's not going anywhere, and unfortunately it's much more difficult to control, I suppose. And also we need some very sophisticated and highly costly technology to evaluate and to quantify the chemical pollution. But the combination is fantastic, fantastic as in really bad. There are some papers now, a recent one that was published by a group in Italy, that shows that the resin that is actually part of the GRP behaves like a sponge a little bit, and it absorbs on the surface a whole lot of chemicals. So in the end, that tiny fragment that is present in the sediment, or is ingested by a mussel or by a fish, is not going to be only a resin or a plastic. It's going to have a cocktail of other chemical substances surrounding it. And so that is a whole other problem.
Yeah, absolutely. I think also something that came up recently was, and you touched upon the recycling and the need for, there's not a lot of real innovation seemingly happening in this space. What do you actually do with the boats?
Yes.
my priority is to map this data so that we can get the boats out of those critical coastal ecosystems. But then what, you know? There are some organizations or companies that are grinding down the fiberglass composite boats to create new fiberglass products. Some of those new products will go back into the marine environment. So I wanted you to speak a little bit to that, because I know we both share the same concern about putting, first of all, grinding fiberglass down, as your research has shown that it behaves asbestos-like, so we don't really want that in that format spraying out into the environment. But also, what happens when we try and recycle our way out of the problem? Are we going to lose the structural integrity of the material? And if it's created then into another life of a marine product, are we just essentially recreating the problem, and perhaps even with less structural integrity?
I think it's, I'm not a specialist in recycling. First of all, yes, grinding, it's an absolute nightmare unless there is a super tight, controlled environment where all this is happening. With absolutely no leakage to the environment. I don't even know if that exists, but that would be ideal if you want to go down this route. Creating another product is, like we say in England, it's kicking the can down the road. But in the absence of any other better idea, probably we have to embrace some of those technologies. I know there are some companies in Italy, for example, that they don't necessarily create another boat or anything that is kind of aquatic, with an aquatic purpose. They just create some furniture, some small tables, small chairs, or benches to be put in the park or something like that. It might be a solution for thinking of the scale of the problem. We don't know the scale of the problem. We just imagine that it's massive, and I think it's more than massive. And what do you do with those boats that at the moment their only trip is to landfill? Think of small island nations. England is 3 times smaller than France, and yet we have more population. We're surrounded by harbors and ports. We're an island. People own boats. What do you do? How much landfill is available to go and dump the boats over there, when actually the UK government pledged to reduce the amount of rubbish that is going to landfill by, I think, 60% or something, fantastic if that happens. Well, only 2 or 3 boats going down to landfill account for probably my entire neighborhood. So that's where we kind of need to be a little bit realistic and think, what is the solution now at the moment? What can we do now? There are sites in the United States and in Germany where turbine blades that are made of GRP are buried because they don't know what to do with them. But they have the land. They can hide the problem until they find a solution to the problem. We can't do this with the boats, so it's difficult. And that's why I said that the boating industry in all its magnificent splendor, I think it could be a little bit more interested in supporting those initiatives to recycle, to find a solution. I'm sure there are some, very, very clever people out there that have all sorts of ideas. They just need to test them, to try them. They need a bit of support, and something will come up.
Yeah. On the policy side of things, we have had interesting discussions about this. You hosted a GRP symposium at the University of Brighton last year, which I was very lucky to attend and present at. The policy side is very interesting for me personally because, as you know, I'm based in France, you're here in the UK, and everywhere I go and talk about this issue, France is touted as having found the solution regarding policy. So in 2019, France adopted an eco-tax, which is placed then on the production of all new recreational boats. And then a pool of money is then designed to be reinvested in the removal and the proper disposal of end-of-life boats. The issue is, as I'm seeing it from being in the field, is that it doesn't seem to be making a dent on the problem. So again, critical lack of data, which is why we're doing the mapping and citizen science. But there are estimates that at the time of this policy implementation, there were, say, 300,000 end-of-life boats already in France. And then there's estimates that there are about 10,000 new boats entering the water. These are recreational boats every year. Now, APA, the great organization who has been tasked with the removal and has set up these responsible waste disposal facilities all over the country, or not all over the country, but there are a few, just they don't have the means to really make a dent on this. So they're removing a few thousand a year. But if we've got 10,000 new ones entering the water and there were already, over 250,000, the problem is only growing. Yeah. In France and many parts of the EU, we have boat registration. In the UK, you don't have boat registration. And I know this is kind of a touchy subject because a lot of people don't believe there should be boat registration because, then it can create this thing for only the rich, and sailing is already very much associated with, money to have access. Yeah. But on my side, I can document all the boat registrations on the abandoned boats. The issue is, who's going to call up the owner? Yeah. The owner's not going to be able to afford it. The owner might not even be here anymore. Yeah. Or the owner might have passed it on to a family member who never had the means to be able to take care of this boat. So from the policy advocacy point, what are your thoughts? Looking at it kind of, I guess we're going to look at it more of like a regional EU-UK thing because that's what we know better. But we've talked about OSPA before, which is the body looking after the health of the North Atlantic Ocean, and perhaps having fiberglass classified as hazardous material.
Well, that's exactly the point. I think if we are hoping for a change in legislation, I think we're very naive. That's not going to happen. And I think our solution, and in fact this is the ethos of my research, is to actually demonstrate that this material is hazardous, and it's going to change massively. It's going to change the problem, because at the moment any abandoned boat is rubbish, is considered rubbish. So whether I go in the estuary and I dump my black sack of rubbish from the kitchen, or I leave my boat over there, is considered exactly the same. And unless they caught me in the act, nothing is going to happen. Somebody is going to take that rubbish, dispose of it, and it's okay, there you go, unfortunate. The moment we demonstrate that the GRP and the boat, it's a hazard, then that changes the problem. Then the search for the responsible becomes, a real active search, and the owner is going to be, forced to do something. It's pretty much similar to dumping the car. I can't go and dump my car on the beach in Brighton because, it has a registration, but at the same time, the car is considered a hazard. And one of the things that is making a car hazardous is actually the presence of asbestos that is present in the catalyzer of the car. So that is why there are only specific companies that are actually dismantling the car and are involved in all this car recycling and so on, because of that asbestos that is present in the catalyzer, and so they need to have a special attribution and approvals and so on. Well, that little bit of asbestos is like this, catalyzer. consider the boat. It's all asbestos-like. So if we demonstrate that there is this massive impact on the environment and massive potential impact on human health, that changes the problem completely. And then suddenly a boat abandoned is not going to be just rubbish, and it's not going to be left there to rot. Is going to become the responsibility of somebody, whether that somebody is the authority that is in charge with keeping that environment safe, or the owner, if that can be traced at the end. But things will change massively at that point.
Now, oysters and mussels, bivalves,
Yeah.
are filter feeders.
Yeah.
And so you explained why, these microparticles are ending up in their gills. And I showed that, we're finding this with the kids in every sample that we're taking. Some people believe that you could just dump a bunch of oysters and mussels into the waters and they'll eat up all of this microplastic and fiberglass pollution, and then that's solving the problem. Can you talk on this, because I know this is this is an issue that we're both concerned about as well.
So I think it's been decades since this idea of using filter feeding organisms, and especially mussels and oysters, as filtration device, if you want, to make our waters clean and to get rid of various anything from chemicals to pathogens and microplastic, for example. Yeah, that seemed like a good idea. And I know that there are areas in Spain, for example, where they put ropes of mussels in front of popular touristic areas to clean up, especially pathogens, especially E. coli or any other fecal pathogens. And it's working, indeed, it's working. They do their job. There is this ethics problem. Is that normal to sacrifice, other organisms to clean up our mess? That's the first thing. I mean, as a researcher and especially as an ecotoxicologist, I've been running experiments on organisms my whole life, and I have to say that every single time we go through a very, very strict and rigorous ethics check. Do you really need to do that? How many organisms do you use? What's going to happen with the organism at the end of the experiment? How many samples do you need? Would you keep some more samples for future research so that you don't go back and take some more? Just use what you have. So everything is questioned, and rightly so. It's not normal to use the organism to clear up a mess. And then there is the other problem. Okay, those mussels are going to eat, or oysters are going to eat or ingest plastic, chemicals, whatever. They are part of the food chain. They are going to be predated by anything from some snails that are able to crack the shell and suck the flesh out, to birds, to crabs, to fish, to otters or other vertebrates, other mammifers that are present in the water. So you are creating basically, a very quick transfer of a massive flesh containing plastic, microplastic and chemicals going straight into the fish, and then further on up to humans. And that's going to be a lesson, for us to digest actually at some point. So yes, there is a limit when, yes, you do have a massive algal bloom, for example, in waters, and then you need to clean the waters. Yeah, you throw the mussels over there and the oysters, and they're going to clean the algal bloom. Although chances are the algal bloom is going to, it's initially set up by some chemical pollution, but in normal cases, when you have too much algae in a place and you want water to be cleaner, oysters and mussels are going to do their job. Using them to suck up chemicals and plastic, I really don't think it's a good idea.
Yeah, and we are also seeing it's a copious amount. The kids are led by your ethics discussions. I'm very selective of how many organisms we take when we do our field work. We have 4 groups of about 6 kids or 5 kids, and now we just do 1 organism per table. So we're taking 4 organisms. I try and do 2 mussels and 2 oysters. I was very conflicted when I found the native European oysters. I found 2. We ended up just taking 1 and leaving 1. And as you said, don't touch them after November because they go into their reproductive peak. But I wanted to test that because I thought that particular organism will get attention if we do find contamination, which we did. But we're very careful to cut up pieces of 1 organism and test several pieces from the gills. Getting onto back to the more citizen science and how people can participate not only with the data collection but the dissemination. A lot of the sites that I'm visiting, I'm finding we have the obvious ones that we drive past every day and we can see the dump boats, and we're going to do very particular work where we first started by mapping them as a cluster, and now I'm going to actually go and document every single individual boat quite detailed. But I'm finding other sites very easily by Googling boat cemetery. So in France, there are sanctioned boat cemeteries. Now, they're typically historical, cultural, tourism sites designated for preserving the stories of a wrecked wooden vessel. But the wooden vessels might have styrofoam insulation or have been repaired with fiberglass. They're not even that old, some of them. The one particular boat cemetery site that I've visited 3 times now has a handful of composite fiberglass boats that are more modern, smaller sailboats, little dinghies, dumped next to these protected sites, protected for their historical and cultural value. So how do we change the narrative? And how can the everyday community member or the creative practitioner be a part of changing this narrative?
Well, I think it's very easy to include, all this impact to the environment. And I recently saw, I was talking to a collaborator in Finland, and she was out showing me on the lake shore, showing me some abandoned boats, and she had a black fleece on her, and she just swiped one of the boats, and she showed to me, look, this is what you get if you just brush past the boat. And it was just a multitude of splinters of fiberglass, and I was horrified. I said, take that coat immediately and dump it, So is this idea, what kind of protected site is that, where you can get, a multitude of microparticles that are so impactful to the environment and to human health. And yes, that idea of dumping ground is general. It happens here in the UK as well. Once you get an abandoned boat, the next day you're going to get a fridge, freezer, and the other day a mattress next to it. I think the whole preserving the stories can be preserved by pictures. You can take pictures and you can create an exhibition, or a site in the, Hotel de Ville or Mairie in center town. You can put few pictures for the people to remember the stories of whatever old boat. But having those cemeteries, it's completely out of touch, and it definitely has a big impact on the environment.
We asked the students, so these are 13, 14-year-old students in Catrium, the equivalent of grade 9, I think, in the UK or Australia. We asked the students when it was a high tide, and we were on the bridge looking over to our everyday cluster of bad boats that are right in front of the school. And I said, okay, now imagine all of those boats are gone. What do you see? What would you see? And they were so excited. They were like, birds, more oysters and mussels, more plants, space that we could play. These kind of things. So I think that, I mean, I would love to see some creative output where we have, you know, a wide photo or painting of the bad boats, and then it's removed and what it could look like then, and how people and wildlife can enjoy that and thrive without it. I have bumped into a number of photographers in the past few weeks, French photographers, everyday citizens who have hobbies in photography, and we get talking because I've got my camera and they've got their camera, and they're like, "Oh, you're photographing the boats," and I'm like, "Yes, I'm documenting end of life boats to look at fiberglass and paint pollution," and they're like, "Oh, we're documenting the boats for pleasure." So it is something I think that we do need to change the narrative, and I found that the best way to do it is to get people pulling their gumboots on with a handheld microscope and the smartphone, and going and actually looking up close with these boats, because when you get up close to it and you see under the microscope all those cracks and the exposed paint, or you just see with your own eyes the paint peeling off, or you look into the cockpit and you see the floating brown rusty water, the exposed, I mean, so many of them still have the electrical wiring or the plumbing. Recently, I found one with all of the personal items still inside a keyboard, like a piano keyboard, diesel, so petrol tanks, all kinds of stuff, clothing. We've also found that when you look at, if you go on a low tide, and if you look around the hulls as they're sort of like, you know, tipped over on the side when they're on the low tide in these spots, so you're looking in the mud normally because we're in estuaries, we're finding all kinds of accumulated trash. So it can be chip packets or bottles, and lots of shedded stuff from the boat, so a lot of shedded paint, fiberglass chunks. But if you can imagine that when the tides come in and go out, the boats are kind of these big structures that then trap more trash to accumulate. So it not only becomes the issue of people dumping and abandoning a bigger item, but all these little items are then being pushed in by the tides and then getting stuck in there as well. So it is a huge problem that we need to address. To wrap up, do you have any final requests or pieces of advice or just thoughts in general for the everyday community member? Perhaps it's just, you know, someone who is now realizing that they're passing a bad boat or sections of bad boats, or a school teacher or a concerned parent or a sailor who wants to do what they can to help this issue.
So I think the most important thing is to discuss and to spread the word, basically. I had numerous conversations with boat owners that were completely unaware of the problem. It was, you know, heartbreaking to see them talking about the sustainability of the industry or, you know, the activity only in terms of reducing the petrol that the boat is using, or increasing the sail, or changing the sail to make the boat a little bit more streamlined or something like that. So that was all. Absolutely disregard, absolutely clueless about what happens with the boat at the end of life, because, as I said, it's the boats probably are more affordable for a certain population, and then it's easy to just change, you know, take a newer boat, sell the old one, and so on. It's the person that gets, you know, the rubbish boat at the end. And by the way, if you go on eBay, you can buy a boat here with zero. You can get it for free, or £1 or something like that. And that person is going to abandon it at some point, because obviously he's not going to have money to repair it, or, you know, to take it to a breaker.
Or it could be beyond repairable,
It could be. If you take it to a boat breaker, we have one in Portsmouth, and I talked to them, and the minimum fee is about £6,000
Small boat.
for a small boat, but to dismantle it, to take the wood separately, the cable separately, and so on, as it should be. £6,000 when you paid nothing, or £1 for a boat? I don't think so. So spread the word, just talk and make people aware that there is research and there is defined impact on the environment and also on human health. And there should be, more voices to create this awareness and to ask for, the strict regulations. Somebody needs to be responsible for that end of life boat.
And I think as a final, passing comment, there are so many different non-profits and organizations and community groups that are focusing on ocean pollution, microplastics. I had a meeting with the bird organization last week. It was the first I'd ever kind of heard of it. It's obviously now in their minds because birds eat, potentially contaminated organisms. What I would say is we need to be finding a way to get this message into these existing citizen science programs as well. Beach cleanups, estuary, bird watching, microplastic research in schools, in organizations. It is really easy to slip in this RETIS project where they're also then looking at observing the bad boats and the biodiversity and adding to this global database. So if you're already involved or if you're already running an organization that's focused on aquatic ecosystem health, this project can become a part of your existing programs.
Yeah, definitely. I mean, coming back to one of the questions that was asked at the beginning is, in a way, we are lucky because we have those, massive boats that can't be ignored and easy to document, easy to photograph. Compared to, chemical pollution, we talk about forever chemicals, about the FAS, the anti-flammable substances. It's quite difficult to involve, citizen science in that. But when it comes to those coastal structures that are there, massive, visible, you can see the crumbs around it. You can even see, oysters and mussels ingesting them. Then yes, we just need bigger voice, more evidence and bigger voice, and hopefully we can raise the flags in the right places.
And just get out there. I found personally through doing this work that the more and more I spend in the estuaries and the rivers documenting, it started by mapping the boats. It's moving towards an obsession and a huge love of estuaries, and now wanting to know how they work and what's important about them, and falling in love with every part of it. So I would say get out there and do the mapping work by yourself in a small team of friends. I do it with my kids. I know other families doing it together. With friends, whatever. So I'm going to just switch back to the final slide. So how to get involved, go onto our RETIS homepage. We'll just switch to that quickly here. There we go, floatingstorieslab.org, and you'll be able to find the RETIS page under Citizen Science tab. You can download the PDF of the maps. The pamphlets. You can click on the map and you can see it's updated in real time. You might have to refresh your browser, but we have some nice populations of data being collected at the moment in the Finisterre region of Brittany and on the Isle of Wight in the UK. Our pilot project has been based in Brittany, and with our colleagues and partners in the UK, that's why we're seeing these regions. But you can add to this from anywhere in the world, and the more data we get in here, the more we're going to be able to know. Scientists can hop on the map and start to see clusters, and then maybe pivot their research to potential actual geolocations. And if you have any questions, you can email me through the website. You can hassle me on Instagram. You can find us. We're all over the place on social media. You have the Bad Boats Field Guide video here on YouTube, and this video is going to stay up on YouTube as well, so you can refer back to any of the scientific information. You can send me any questions for Corina. I'm always bugging her with more questions, so I'll be able to relay answers. Thank you so much, everyone, and that's it for today. Thank you.